This is a presentation brought to you by Storm Technology. Today I will be discussing Visual Studio Team Services, Release Management and Test Automation. So here's the agenda. I will start by introducing Visual Studio Team Services before moving on to Release Management. I have 4 demos. The first is on continuous integration and continuous delivery. I will show you how to create a build and release definition. I will also show you how to create multiple environments with different configurations. Later we will discuss testing, and I will show you how to create a unit test project and a coded UI test project, and I'll show you where they fit in the build and release workflow. So let's start with Visual Studio Team Services. Team Foundation Server is a Microsoft product that provides source code management, requirements management, automated builds and testing, and release management capabilities. In fact, it covers the entire application lifecycle and it enables DevOps. Team Foundation Server is available in 2 forms, on-premise and online. The latter is called Visual Studio Team Services, formerly Visual Studio Online. The cloud service is backed by Microsoft's cloud platform, Microsoft Azure. It uses the same code as the on-premise version with minor modifications, and it implements the most recent features. Visual Studio Team Services requires no setup. A user signs in using a Microsoft account to set up an environment, start creating projects, and adding team members. So what is release management? Release management is a service in Visual Studio Team Services that helps you automate the deployment and testing of your software in multiple environments. If you look at the diagram, you can either fully automate the delivery of your software all the way to production, or set up semi-automated processes with approvals and on-demand deployments. It is an essential element of DevOps that helps your team to continuously deliver software to your customers at a faster pace with a lower risk. To use release management, you create release definitions in which you specify the automation tasks that should be run in each environment. These automation tasks can be to deploy your software and to run tests against them. You can group multiple environments in each definition to model your software lifecycle. You can then set up the deployment in each environment to be automatically triggered upon the completion of a build, or at scheduled times, or on a successful deployment to a previous environment. You should consider release management with Visual Studio Team Services if you use continuous integration. Whether you use Team Build from Team Services or Jenkins as your continuous integration system, you can set up release management to automatically deploy new builds to multiple environments. You need to track the progress of your releases. If you use several environments for your tests, release management helps you to monitor whether a release has been deployed and tested. Release management also tracks whether an issue fixed by a developer or a product backlog item completed by your team has been deployed to a specific environment or not. You develop applications and you need to deploy them regularly to any platform. But release management has many out-of-the-box tasks to deploy to a variety of applications. You need control of your deployments. Release management lets you specify which users can change the configuration of an environment, or approve the release to be deployed into a particular environment. If there is a problem with that deployment, release management helps you to roll back, and it provides all the logs in one place to help you debug the problem. You need an audit history for all your releases and their deployments. Release management provides a history of all the changes to the definitions and configurations. It also provides a history of all the activity performed during each deployment. So our first demo today, I will show you how to create a build and release definition to illustrate continuous integration and continuous delivery. So this is Visual Studio Team Services. On the top we have the Build Hub. So I'm going to click on the icon here to create a new build definition. I'm going to select Visual Studio. I'm also going to check the box to say continuous integration. So straight away we're given 6 steps, and we could use these 6 steps and it would create a build for us. But I don't need them all. I don't have a test assembly yet, so I'm going to remove that step. I'm also going to remove this step here to copy files to an already configured directory. I'm going to remove this step here because I'm going to create my own artifact. An artifact is a deployable component of a build. The web application we'll be using in our test is just a default out-of-the-box MVC web application. So I've already checked in the code into the repository. So I have access to that here in the build hub. So I'm going to create an artifact for my web application. So I'm going to browse to where the web application is deployed, which is in here. It's in a zip. So I published the web application into a zip file. I'm going to give it a name. I'm going to call it web app. I'm going to put it on the server. I'm going to save that. So my build is ready now. So if I go back to the web application and make a code change, for example, I'm going to add a test comment here. Save that. So when I check this in, it should kick off a build automatically. So that is checked in. I'm going to jump back to Team Services and click on Builds, C and queued. And there's my build waiting in the queue. You can also view the change set. You can see what I actually checked in. This is handy if the build fails. You can see what was the most recent code checked in, and you can review your code in your web application. So if I double click on the queued build, you will see a console window. And you can watch it going through each of our steps, creating our build. So it has gone to NuGet and downloaded any libraries that the build needs. It's now compiling our application. And finally, it's just creating our artifact, which is our package, our web application. And so the build has succeeded. So what we've illustrated here is continuous integration. If you can imagine a team of developers all working away, checking in code at different times, the build will kick off each time, and you'll be notified if the build has failed, so you can review your change. The second part of this demo is to create a release definition. Now that we've created our build, it's in a deployable state, so we can move it across into the release hub and deploy it. So I'm starting by creating a new release definition, and I'm going to deploy the web application into Azure. So I'm going to select continuous deployment. So any time that there is a new build ready, it will create a deployment for me automatically. So here's our environment, and I'm going to call it dev. I'm going to remove this step run test because we don't have tests yet. So earlier I created an Azure subscription. I went into services and created a link to the Azure endpoint. I can now use this in team services. So you give our web application a name. I'm going to use the time. I'm going to put it in our Europe. And I'm going to select our zip file. There it is, there's our application. And that's all you need. So if I save that, our release definition has been set up. So if we go back to our web application, and if I remove our test comment and check that in, it should kick off a new build. And once that build is successful, it will create a new release definition that will be deployed automatically. So that's checked in. If I go back to our build hub, a new build has been created. You can see that this line has been removed. So once again, the build is kicked off, creating a new build for us. So now our build is successful. If I look over at the release hub, we can see that a release has been kicked off. So if I look in the logs, you can see that it's now deploying our web application into Azure. You can see here in the log that the web application wasn't created. So it's going to create a new application for us in Azure. If it did exist, it would just overwrite it. So our release has been successful. So I'm going to go just to make sure, view the web application. So I think we called it web app 1829, I think. And there's our web application deployed. Visual Studio Team Services gives us this history, which is useful for reviewing over many deployments, and you can full traceability on what code went into each release. So in this demo we have reviewed continuous integration and continuous delivery. In the next demo I will show how to create multiple environments. So in the release hub we will be creating a QA environment and a production environment, and I will show how to set up continuous delivery for those with approvers. So in this demo, I'm going to show you how to configure multiple environments with different web config settings using Visual Studio Team Services. So if we pop back to Team Services and click on the Release Hub, we'll see from our previous demo there was just one environment, a dev environment. So in this demo we're going to create some more environments, maybe a QA, a pre-prod and maybe a prod environment. The only difference between these environments will be web config settings. So this is to mimic like a real-life example where you might have different environments pointing to different databases, different APIs, maybe different settings in their web configs. So there's two ways you can change these web config settings. You can use a script, and using a script you can only change app settings and connection strings. Or you can use the tokenization approach where you have much more control and flexibility, and you upload the web config using FTP to Azure. In this demo I'm going to use a script. If we pop back to my web application, this is the script I created earlier. It's just a simple basic script, and we will be passing in the website name we want to change and the app setting, and that's it. So let's create another environment. So I'm going to clone the dev environment because the web application is already set up. I'm going to have it to automatically approve itself. I'm going to call this QA. So I'm going to give it a different name, 1938. And I'm going to create a new step now to Azure PowerShell. And that's going to run our PowerShell script that's going to change our web config setting. So I browsed to that artifact, I added it just like I did with the web application. Here it is. So this here is the parameters I need to pass through. The web application name, which is we've called, and just to confirm, 1938. And background color is the variable I'm going to be changing. In our application, I have a web config setting background color. In this setting, it just changes the background color of our web application. So in our demo today, we're going to deploy a web application to our dev, our QA, and our prod environments. And the only difference is going to be the background color of the web applications. So these are the parameters we're going to pass into our script. And if I click on the environment config variables, it's in here. Then I make the actual I set the new value. So background color was the name of the web config key. Background color. So I'm going to say in our QA environment, make the background color blue. Let's save that. So that's all that's needed to set up in the setup. I'm going to create another environment, and I'm going to call this one. I'm going to call it pre-prod. And again, I'm going to change the name of the pre-prod website to 40. And I'm going to put that as my parameter to my script. And inside here in the config variables, I'm going to change the color to red. So in dev it's going to be silver, QA was blue, and production was red. And finally, just to illustrate approvers. Approvers in Visual Studio Team Services is when a release is successful but not deployed. This is where when you're setting up an environment, you set that it doesn't automatically deploy. you can set a member of your team to manually come in and do that step. So in many instances, this might be seen as more a cautious approach. So I'm going to set Philip there to do the manual deployment. So we're going to have continuous delivery to our dev, QA and pre-prod environments, but our production environment will actually have an approver right at the end of the process. Okay, I think we're ready to kick off our new release. Let's save that. Okay, and now we can manually kick off the release. Obviously, it's set up for continuous integration and continuous delivery. I could check in a code, but then that would kick off a new build, which just for time-saving purposes, I just manually kick off a release. So I'm going to select the most recent successful build. So if we look into the logs, we'll see the first one that's going to be run is dev. So that'll be deployed first, following QA, pre-prod. But prod then will wait until the user we assigned Philip to come in and manually do the final release, final push. So again, we have the logs which we can watch. So it should take about maybe 2 minutes to deploy the 3 web applications. So that's QA deployed, and you'll see straight away QA will be kicked off next. So while that's running, I'll open up the QA environment, that web application, so 29. So still with the silver background, which we expected. So in the QA environment, we're expecting, I think it was blue. Yeah, blue background color. So that's still running there. So QA is deployed there now. So we'll open up the QA environment and hopefully we'll see a different background color on that. Let's see, it's 38, so just 38 there at the end of this one. Great, so you can see that that has worked. Different background color on QA. So now it's deploying to our pre-prod environment where we had a red background color. Okay, there's pre-prod that's deployed. And okay, that, and this website was called 40. And we should see a red background on this one. Great, so we have 3 different environments with 3 different background colors, illustrating that we're changing the web config settings without actually having to create a new build or check in code or anything like that. So very flexible to change settings. And you can see that prod hasn't been kicked off. And the reason for that is waiting for the user Philip Duggan that we set against it to come in and to manually deploy that one to production. So as you can see, it will stay in a not deployed state until he will get an email telling him that the build is ready to be deployed. So what we've illustrated in this demo is setting up multiple environments with different config settings. You can use a script or a tokenizer, depending on how much control you need over the web config. In our next demo, we'll move on to testing, and I will show you how to create a unit test project and for it to automatically run in our build process. This is a demo on unit testing using Visual Studio Team Services. So if we pop over to the build hub that we created earlier, I'm going to add one more step in here, and that is a unit test project. So it's going to pick up any project in my solution with test in the name. Click Save. So if I go back to my application, I created a unit test project with one simple unit test in it. So I'm going to change this test to fail. So I'm going to check this in, and it will kick off continuous integration. As you can see there, our build is queued. While we're waiting, it's worth discussing what unit tests actually are. At a high level, unit testing refers to the practice of testing certain functions or units of our code. This gives us the ability to verify that our functions work as expected. That is to say that for any function and any given set of inputs, we can determine if the function is returning the proper values and will gracefully handle failures during the course of execution. This demo is not about arguing a case for the level of tests you should have in your project, but to demonstrate the value of having a suite of unit tests in your build process to verify the integrity of the build. So as I've said, our unit test project should fail. And this will automatically create a work item in TFS. So there in the logs we can see that it has failed. So if we jump up into the test hub and into runs, we get more detail and analysis on the failure. So as you can see there, one unit test has failed. If we go into test runs, it will tell us what actual test failed. In our case it was called test method 1. It'll tell us why it failed. It will actually tell us the line it was failed on. So if you had a library of many unit tests, this would be a very powerful tool in the process of finding which unit test has failed and giving you a good analysis on how to fix it. If I click on the work hub, you can see there's a work item in TFS, and that can be assigned to a developer to fix. So if I pop back to my application again, I'm going to prepare the unit test. So as you can see, using continuous integration, our build is kicked off again. And in this case, we expect our build to pass. So having a good suite of unit tests in your project is one way of verifying that your project So as you can see there, our unit test has passed, and so we expect our build to be successful. In the next demo, we will discuss automated coded UI tests. These tests drive your application through its user interface. We will create a VM and deploy our coded UI test there to test our application. This is a demo on coded UI testing using Visual Studio Team Services. So before we get started, what exactly are coded UI tests? Well, they are automated tests that drive your application through its user interface. These tests include functional testing of the UI controls. They let you verify that the whole application, including its user interface, is working correctly. So in a previous demo, we created a release definition with these four environments: dev, QA, pre-prod and prod. So in this demo we'll be making changes to the QA environment. We'll be adding some new steps that will create a VM for us where we'll copy across the coded UI DLL and we will run those tests in that VM. So if we pop back to Visual Studio, I've created a very simple coded UI test project. We also need to create an Azure resource group project. So we go add new project, cloud, and Azure resource group. In this, we're going to be, this project is used to create a new VM for us. So we just we set up in this project to create a virtual machine. So this project will create everything we need to create the virtual machine. So when I check that in, put it part of the build, create an artifact for it, we'll be able to use it in the release definition. So I have disabled our build definition for continuous integration just for now. So when I check in this, it won't kick off a new build. So I check in the resource group and the coded UI tests. So we need to create two new artifacts, one for the resource group and one for the coded UI test. So go add new step, build step, publish artifact. So there's two of them. So the first one we'll do is the resource group. The second one is the coded UI project. Okay, save those into our build definition. So we manually kick off build. So it's just publishing our two new artifacts, the resource group and the code UI test. Okay, our build is successful. So now we pop over to the release hub. We edit our release definition. So we're going to be adding our coded UI test into the QA environment. We could of course add it to the other environments, but for this demo we'll put it in QA. Okay, the first step we need to add is the resource group deployment. So we add that, and we change some of the settings here. So we're going to use the resource manager connection type this time, which I've set up. So create our update resource, we need to create the VM. I'm going to use the Hello Azure Resource Manager, which I've set up earlier. North Europe. So we browse to our artifact and into templates, and we select this first JSON file. The template parameters, it's in the same directory. That one there. But we also need to pass in some other parameters. So we need to pass in a username, an admin password, and a DNS. So I'm going to copy this line. We put that here, just like we did with in the earlier demo where we were overwriting the web config. We're passing in our own parameters. So if I jump into configured variables, so we need one for VM user, VM password, and DNS. So this can be anything, so I'll go my DNS and the time. Okay. Enable the prerequisites. I need to copy the resource group down here as well. That's all I need there. The next step is to create an agent. So into tests, Visual Studio Test Agent Deployment. If you've ever installed a Team Foundation server onto an actual server, configured it yourself, you would have had to create application tiers and data tiers and build controllers, agents. You don't need to do that with Visual Studio Team Services. So we're creating that step here, just to create an agent to pass across to the VM. So we use my DNS name as the machine. Just get that out again. So it was my DNS dot make sure that name, it's oh yeah, North Europe, which is where that's the center I'm using. North Europe dot cloud app dot azure.com. Okay, so I'm going to use my variables I set up. So I'm going to go VM user here, VM password, HTTPS. Yeah, username and password down here as well. Interactive process, which it is. Okay, that's all we need for the test agent. Next task we add is to copy the files across to the VM. So we're copying across our DLL here. So browse my artifact. To the build folder, or into the bin folder. Select that DLL. Again, we're using our resource manager. That's set up earlier. The destination type is VM. It's against this storage account where I've pointed. I've hooked my endpoint up to. Resource group was the hello one. Okay, pass in our credentials here again. VM user. VM password. Destination folder. So where do I want to put the DLL on the VM? I'll put it into a folder called UI tests. Enable the pre-wet script again. That's it, I think, for the copying of files. Yep. Okay, so our final step then is to run the tests. So it's Visual Studio functional tests here. So where you run coded UI Selenium tests. So what's the name of our VM? So it was mydns.noreurope.cloudapp.azure.com. The location where I put the test was on the D drive. And in the D drive it will look for the UI test folder and any project with test in the name. So there should only be one. Okay, I think we're set up there. There are 4 new steps. So in QA, we're going to deploy a website to QA, change some web config settings if we want. We're then going to create a VM and deploy our coded UI test DLL across there and run the coded UI tests on it. So I'm going to save that. Just to make sure I've all my variables, VM password, username, DNS. Yeah, I think we're good. So I'm going to kick off a release. Use the latest build. So dev will be deployed first in QA. So when you're deploying the QA first time round, where it has to create the VM, and that can take a bit of time, could take 10 minutes to set that up. But after you've it set up, it will look for the VM and will update it rather than creating it. So the second time round your release will be a lot quicker. So while we're waiting for that, I'll just pause the video and I'll come back to it when we're at that point. So we're at the step now where it's creating or updating the VM. So in our case, it's creating the VM. So it's just creating our VM there. Okay, so it has created our VM. So the next step is going to copy across the test agent. And while it's doing that, I can pop over to Azure, and we can remote desktop into the VM. So here it is. See into the logs there, it's just copying across the agent, setting it up. Okay. So as we can see there, that's the agent that's up and running there. That DOS window signifies that. Okay, so the agent is finished running, so now it's copying the files across. So we should expect to see a UI test directory created here for us. Okay, so there's the UI test folder created with our DLL inside it. Great. Okay, so the last step is to run the test. So we're here in our VM. So the coded UI test will pop up a browser and run our simple tests. Okay, I think it's happening now. Okay, so it's just opened IE. It's going to browse to our web application. So the tests I have are very basic. So the first time you run it, you might need to allow it to access the websites, but because what in your process you'll be um, reusing the same VM over and over, but it will be a task in your release definition to create it the first time around and to update it if it already exists. So it's done the first test, it's now doing a second test. I have 3 simple tests, so the third one. Okay, so you can imagine if you had a suite of tests, it would go through them all. They're doing the manual steps. Without the manual steps, it will run all your tests automatically. Okay, it should just yeah, that's the end of our QA environment testing, and it runs on to pre-prod, where again you could have your suite of tests in here again to run. We don't have it set up in our environment, but like I said, you could add your coded UI test steps into pre-prod as well, but it's just not the way we've set up our release definition. So what you're seeing in this demo is how you can add in coded UI tests into your release definition. So we created a resource group that would create the VM for us, a VM to host our coded UI tests. We deployed the test agent onto the VM, copied our DLL across, and the tests were run. So that's the process. So what we've seen across the 4 demos are, I suppose, a DevOps tool in Visual Studio Team Services that supports continuous integration, continuous development, delivery, testing. I suppose agile methodologies speed up the development and test cycle and make sure that you can deliver to customers regularly and consistently. And using Team Foundation Server, Version Controller, or Git, it's not just for storing your source control. You can, as we've seen, you can set up continuous integration builds that run every time a code is checked in, and you can set up tests, then be unit tests, coded UI tests that you can test your user stories and test plans easily and provision different test environments for them to run in. And there's full traceability of all your build and releases as well. So release management, I suppose we've seen that it helps automate the deployment and testing of your software in multiple environments. You saw that when we changed some of the config settings in different environments. We saw that we can fully automate it through continuous integration, continuous delivery, where on successful builds and it'll do deployments. But you can also have the process of approvals, which kind of facilitate an on-demand deployment, where a team member can come in and manually kick off the release cycle or the build process. So these tools help your team to continue to deliver at a faster pace and with lower risk, and improving efficiency between your teams. So for more information on this, you can go on to Storm's website, go in and look at our application lifecycle. So there's a link for that. You can also go to visualstudio.com, where you can download free trials of Visual Studio Team Services. You just need a email address to set it up, and you get 5 user licenses. And go on to Azure. Likewise, you can get a free account there for you get an allocation of some time and resources on there per month. And visualstudio.com is a good place for resources. So that's our demo for today. If you need to contact Storm Technology, you can do so here with these addresses. Thanks for watching.